Hey everyone, I'm Dominic and I'm going to present assumptions underlying cryptocurrency de-anonymizations, which is joint work with Victoria Wonge and Christian Rückert. Let us first start by looking into cryptocurrency de-anonymizations. Throughout this presentation, I'm using Bitcoin as an example, while in the paper we are also covering Monero and Zcash. In Bitcoin, there's a public ledger of transactions which is maintained in a peer-to-peer network. The ledger is also referred to as blockchain, as transactions are organized in blocks. Here you can see a simplified version of a standard transaction in Bitcoin. It consists of a list of inputs and a list of outputs. An output denotes an amount of Bitcoin and a public key, or to be more precise, the hash of a public key, which is also referred to as an address. Inputs, on the other hand, are just references to outputs of prior transactions. So you can say a transaction is actually spending yet unspent transaction outputs. It has been shown in Bitcoin's early days already that addresses are linkable. The arguably most famous heuristic for address clustering is the so-called multi-input heuristic. It has been already mentioned in Bitcoin's white paper. The idea of the heuristic is that all the addresses in the inputs of a transaction are linked. And it is based on the observation that in order to create a transaction, signatures are required that verify under the respective addresses or public keys. Let us now switch to the assumptions. And we stick with our example of the multi-input heuristic. The assumption underlying the heuristic is that all inputs are controlled by the same entity. However, this assumption is not true for all transactions. In 2013, CoinJoin has been proposed, which is a mixing protocol that relies on so-called CoinJoin transactions. And in a CoinJoin transaction, the inputs are controlled by multiple entities by design. So now you might wonder, why should we care? If an assumption is not that reliable, this might not be a problem in a research paper. However, cryptocurrency de-anonymizations are used in practice and especially in criminal investigations. One famous example is the Wall Street Market case. Wall Street Market was a darknet marketplace where you could buy, in particular, drugs. The marketplace had 3 operators, and US Postal Service conducted a blockchain analysis to identify one of those operators. So in general, if investigations are conducted, such as search of premises, surveillance, or pre-trial detention, suspicion is required. If there is no suspicion, then the investigation would be unlawful. So if an investigation is unlawful, all the evidence obtained might be inadmissible in court. So uncertain assumptions might raise the following legal issue. And if we go back to our example of the Wall Street market, the question is, if we want to conduct further investigative measures against the operator identified by the blockchain analysis, the question is whether this identification actually establishes the required suspicion for those further investigations or not. Another problem here is that we don't even know which assumptions were actually used, as the US Postal Service just states in the criminal complaint that proprietary software was used. So the software could, for example, be by Chainalysis, CipherTrace, or Elliptic, just to name a few of the main players in cryptocurrency de-anonymizations. So the next question is, what can we do about this? How can we address this legal issue? And the first thing we did is we proposed a taxonomy of assumptions. We distinguish user behavior, protocol, computational hardness, and statistical assumptions. User behavior assumptions are based on the behavior of users, and we already saw an example, namely the assumption underlying the multi-input heuristic. Protocol assumptions, on the other hand, are not based on user behavior, but on the implementation, the network topology, and other aspects of the protocol. Here's an example by the work of Tramer. It is the response time assumption, and it is strike true because it has already been fixed. The attack was originally proposed for the cryptocurrency Zcash, but I will explain it at the example of the peer-to-peer network we saw before. So imagine that a node, here the red node, receives a transaction from another node in the network. And further, the red node is also the recipient of this transaction. Then for a subsequent request in a network, it holds that the response time of the node is delayed because it needs to perform additional checks. As it only needs to perform those checks in case it is the recipient of the transaction, the other node sending the request could actually determine whether the node is the recipient or not. The next class are computational hardness assumptions. Computational hardness assumptions are based on how hard it is to efficiently compute a problem or solve a problem, for example, discrete logarithm. And there's a positional paper by Goldwasser and Kalai discussing computational hardness assumptions and their reliability in detail in the context of crypto. The last class are statistical assumptions, and they are based on how likely an event is. And I will give you an example in a second. So here you can see the peer-to-peer network again. Now, if a client connects to the peer-to-peer network, the peers it connects to are referred to as the client's entry nodes. And it is assumed that each client has a unique set of entry nodes. So if the client issues a transaction now and sends it to its entry nodes, the entry nodes will further relay it in the network. If now the other nodes in the network detect which nodes first relayed a message, they can derive the entry node set of a client. But this only works under the no collision assumption. So among the first few nodes that relay a transaction, it is assumed that those nodes are not the entry node sets of another client. So there is no collision. And the authors of the paper, they actually said that the probability of a collision is negligible. So now how can our taxonomy help to address the legal issue? The taxonomy can help in the following way. So if we go back to our earlier example, the question is whether the findings of the blockchain investigation can establish the suspicion required for further investigative measures. And the suspicion depends on the reliability of the assumptions. And with the taxonomy, we can argue this reliability. And to do so, we state the principal rule that reliability increases from user behavior to computational hardness assumptions. And the reason is that user behavior changes, and in order to assess its reliability, one would require ground truth data, which is hard to obtain. Computational hardness assumptions, on the other hand, are well studied in the community, are probably around for quite some time, so they are in principle more reliable. For statistical assumptions, we can't really say anything because they depend on the actual likelihood of the event. Besides this general assessment, we also provide factors for each class of assumptions that help to argue reliability on a case-by-case basis. For user behavior assumptions, these are, for example, ground truth, which I already mentioned, but also false positive detection. So if we go back to our example from the beginning in the multi-input heuristic, the multi-input heuristic is only as good as our way of detecting coin-join transactions. Thus, if we can reliably detect coin-join transactions, also the findings by the multi-input heuristic are more reliable. And finally, there is the support by external information. So if the blockchain de-anonymization establishes a link or leads to a finding, and this finding can be supported by other information, for example, that an address has been mentioned in a darknet forum, this might additionally increase the reliability of the finding. So to conclude, we showed that there is a legal issue with the assumptions underlying cryptocurrency de-anonymizations, namely whether the de-anonymizations can establish the degree of suspicion required for further investigations. And on the positive side, we proposed a taxonomy of assumptions that allows to argue their reliability. And last but not least, here is how you can get in contact.